Chapter 5 is my favorite chapter. You just have to memorize simple equations and that's it. Other than that, you just need to understand what's really going on by drawing graphs and that'll be it. So probabilities is basically law of large numbers. So if I throw a dice, 6-faced dice, the probability of getting 1 would be 1 over 6. But just because I threw a dice 6 times doesn't mean that I would absolutely get 1. So to get the probability of 1 over 6, you need to have many repetitions so you will approach a single number, which would be 1 over 6. And it basically means a long run relative frequency. Second thing you need to remember is complemented rule. Basically, when A does not occur, you would subtract the probability of A from 1. So if there's a C, you will always subtract it from 1. Second thing is disjoint events. Disjoint events means it never occurs together. So if there's a checklist, if you're women and men, you would only check 1, which means that would be a disjoint event. If it's disjoint, probability of A or B, you can just add A and B. While if it's not disjoint, you must subtract A and B. So in a graph, A and B would be this part, and A or B would be this part. You would either get A or B, and S is just the other outcomes. Probably this equation would be the most hardest concept to understand for chapter 5. What's the probability of A given that B? It will be written as probability of A and B over probability of B. However, remembering this is pretty hard, so I'll explain an easier way to remember this. Also, people get confused with disjoint, mutually exclusive, and independent. When A and B is independent, it means that probability of A given that B equals to probability of A. And if that is true, probability of A and B would be probability of A multiplied by B. To understand this concept better, I'll give you 2 examples. So, what is the probability of never? So, probability of never, you just need to get the total and then the probability of never, which would be 0.12. Well, these are already in a probability form, so you don't really have to make this equation, but I would want to make sure that you understand this concept. So probability of never would equal 0.12. Then what is the probability of never and woman? So probability of never and woman, you just find the woman and the never, which be 0.036 over 1, which be 0.0636. That's easy, right? You just need to follow the graph, what they're asking. So, this is the pretty confusing part. Probability of never given that woman. To remember it easy, given that will be always on the bottom. So you will follow the graph. Woman equals to 0.53, right? Given that, the woman and never. So woman and never would be 0.0636. And if you find that, it will be 0.12. What would be disjoint events? Disjoint events would be if it's either men or women, that would be 1, or if it's never, or sometimes, or always. It cannot be men or never, women or sometimes, because that has a probability. So, we want to know if the response never and being a woman is independent. People would easily think that it's not because it's not mutually exclusive. However, if we're finding something's independent, we must write this equation. Probability of never, given that woman, does that equal to probability of never? Let's figure it out. So we have probability of never given that woman equals 0.12. And what is probability of never? Probability of never equals to 0.12. Those 2 probabilities are the same, which means that they are independent. Do not get confused with mutually exclusive and independence. When it's mutually exclusive, it means that it cannot occur at the same time. However, if it's asking for independent, it means that the probability is the same when A given that B would equal to A. Second part is, if the probability is independent, what would we do with that? So, if a clinic tests 200 random selected people who are free of HIV antibodies, what is the chance that at least 1 false positive would occur? So, at least 1 false positive would occur out of 200 people. So, if the false positive probability is 0.04004, my negative probability would be 1 minus 0.004, which is 0.996. To find at least 1 false positive would mean that I have to minus all the negatives from 200 of my outcomes, because 0.996 is independent. My outcome would be 0.5514, and that's how you use independent probabilities. The third example is, there's several probabilities. You will lost your mind reading this, but it's very easy if you use the tree branch method. We would read this problem closely and slowly. Willie Coyotes is pursuing a roadrunner across Great Britain towards Scotland. The roadrunner chooses his route randomly such that there is a probability of 0.8 that he'll take the high road and 0.2 he'll take the low road. So if we read this information, we're going to start by making the tree branch. So there's two routes, right? So one is 0.8, which is the high road, and 0.2, which is the low road. And we will continue reading. If he takes the high road, the probability that Wile-E catches him is 0.01. So we're going to write, if he takes the high road, there's another probability of 0.01 that he gets caught, which means that 0.99 will be the probability of getting not caught. If he takes the low road, the probability he gets caught is 0.05. So getting caught would be 0.05, and if we subtract that from 1, the other probability would be 0.95, which is getting not caught. After you finish this tree branch, it means that you finished everything. So we're finding the probability that he took the high road, given that he was caught. It's the given that probability problem. You would first set the equation saying probability of taking the high road, given that he was caught. We need to find probability of taking the high road and the probability of getting caught and the probability of getting caught. That's where people freak out, but you do not have to freak out. First of all, we're going to find the probability of taking the high road and getting caught. And that is very easy. You just need to follow the lines. Starting from the route, you find the probability of taking the high road and getting caught. And that's just one line, right? And you would multiply the numbers that is shown. And probability of getting caught is also easy as well. You just need to follow the line of getting caught. So if I want to get here, I would go do 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 and do 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 do. You'll get two outcomes, right? So you just need to multiply those two. Multiply by 0.01 plus 0.2 of taking the low road, multiplied by 0.05 of getting caught. And that will equal to 0.018. If I have all these informations, I can set the equation for this one, right? So the probability of taking the high road given that he was caught is probability of high road and getting caught over probability of getting caught, which would be 0.008 over 0.01h would equal to 0.444. We got the answer. Now we just need to interpret it. So you would say there's about 44.44 chance that he took the high road given that he was caught. It's important to interpret your probabilities, and you would say there's about number of chances that So that's it. That's all you need to remember. It's really easy. Now good luck.